Nice to be together with you today. I'm Nedelina, as Saleh has kindly introduced us. I'm the project manager of veraai in Ontotext, and Andre is our research lead. So starting off, just with a quick introduction. Next slide, please, Andre. With the quick introduction of veraai. Maybe most of you have been with us in the other series from these webinars hosted by EBU. But just to have to put some faces in your head, these are all the passionate people that have been working on the project to leverage AI for being helpful to verification professionals. And they're doing very cutting-edge research that we also try to make its way into tools that can be used in the workflow of these people. So this is us, and we have the honor to be part of this consortium. And before diving into the work that we are doing, let us just give an idea who we are, what we are fighting for, so to say. Ontotext is a company that's been for over 20 years working in the sphere of semantic technologies. So we're trying to unlock the knowledge that's hidden in the information assets of businesses. And this gives them the power to have more informed decisions for their business. And since the start of this year, we have united forces with a long-standing partner, the Austrian semantic web company, who are a leader in graph-based search and analytics solutions. Together, we are operating under the brand GraphWise. So we have talented people all over the world, and a lot of customers in different verticals, in financial services, industry and retail, healthcare, and also a well-developed partner ecosystem with industry and academia. So what's our value proposition? This starts with modeling the data. So the information that each company or organization has. And for this, we, of course, use different machine learning and text mining methods. And once we have this, we have extracted and structured this data and have, so to say, enriched it in a way, we can then build on top of it, interlink it in the so-called knowledge graphs, which are a very good basis for efficient information retrieval, analysis, and deriving insights. And then we can use this knowledge graph as the foundation for providing relevant context for AI algorithms. And then we can have a really relevant, trustworthy, and consistent answers from the AI assistants that we all would like to have good answers from. So you will see all this kind of in action in what we have been doing for the project. Yeah, next slide, please. And here we come to our specific work on the project. So first, going from the user requirements and pains that our media partners have analyzed at the start of the project. We can imagine what are their problems on a daily basis. So, for example, you're bombarded with so many claims from different information spaces. And let's imagine that you're faced with this claim this Facebook post that says that 120,000 trees will have to be cut in one of the very important ecosystems in Germany, the Reinhardswald, to build wind turbines. And people start asking whether this is true, whether this has been fact-checked, and then going deeper into what's in it, what entities, what things are mentioned, not only places and people, but other types of concepts. Is this part of something broader? Are there similar claims that can be traced back in time? And then maybe you would ask yourself, oh, is there an easy way to just get the answers through a helpful AI assistant? So we have distilled these into a couple of research tasks. The first one being the ability to recognize concepts across languages. So to find a way to know that, for example, wind turbine is the same thing when you also have Windkraftanlagen, for example, in German. This is the same thing across texts that you have at hand. The other task is to be able to identify the events that are associated with these concepts in the text. The third one is the narratives. As for example, we have come up with an approach that has some spin on narratives, because narratives this is something that has different perspectives on it. But let's say that we can try to group these similar texts in a way that they form kind of a narrative in the time. And the fourth one is leveraging our expertise and the latest advances on top of our graph database to customize an assistant that will use the data in the database as a grounding context and get the answers for the people that are using it in a more efficient way. So now we are going deeper into the tasks, and here I give the floor to Andrei.
Yes, maybe it is sort of obvious, but the first three tasks we mentioned here, we'll go over them first, and they are dealing more with extracting knowledge out of the text and understanding it and structuring it. And they're kind of building in complexity. So in each case, we start with some texts which are mostly claims, but they could be social media posts where the claim is being made, or sometimes debunking articles. And for the first task, we try to identify concepts across languages. What this means is that entity recognition and entity linking are very classical tasks within natural language processing. But our goal here is to do this in kind of two steps. First, we have the algorithm look at the text and kind of point to which words in there seem like they're actually entities or concepts. And the second step, which tries to link it to a large multilingual data set, in this case, Wikidata, which allows us to make these connections across languages. And that linking to Wikidata allows us to unambiguously link concepts and know that even though some concept is mentioned with 50 different names in 20 different languages, they're all really referring to the same thing. The example I have here is showing that the World Health Organization referred to in different languages. So this kinds of entity linking traditionally works most with people, organizations, and locations. But ours is extended to general concepts of all kinds, so it can It includes those, but also mentions of things like book titles or movie names, but also general concepts like HIV or COVID-19, things like wind turbine that Nedelina mentioned earlier. And they can be kind of connections for general themes of things being discussed between the narratives. So our approach has been, we tested two approaches and we evaluated them over a number of languages. As I said, the pipeline currently is a two-step process. The first one recognizes entity mentions within text. So you can basically think of it as just highlighting a piece of text and saying that seems like it's a concept. And the second step, using the mGenre algorithm, which tries to map that string to any concept in Wikidata. So our algorithm works in 105 languages. It's reliant on updates in Wikidata to learn about new things. So, for example, it can recognize things from once a new thing comes up, there's a bit of a lead time before it makes it into the algorithm. For example, when COVID-19 became a thing in February 2020, it was added to Wikidata very quickly, but the process until the algorithm starts recognizing mentions of COVID-19 will take 1 or 2 months. But starting with that time, it will start tagging it in all the texts. And we also experimented with this other state-of-the-art algorithm for the same task, Bella. And while it generally performed better by a not insignificant margin, it has the issue that the dictionaries cannot be updated. So we're kind of stuck with the point in time at which their dictionaries were created in 2022. And we decided to hold off until there's a way to update the dictionaries because in this information, it's very important for your algorithm to pick up important new concepts. And people that become popular, they need to make it into the dictionaries. Things like vaccines and drug developments, various events, and those kinds of things. Okay, the second task, it's kind of building on the idea of concepts, but approaching it sort of from the other direction. We're calling this eventful data, but really it's using this model that looks at individual sentences and tries to answer a series of questions. And the end goal there is that it annotates sentences with information about whether they're talking about an event, what kind of event it is, which is the trigger word, which is the important word that tells you this is that kind of event, and what arguments discovered in there. Now, this is important, and it's a difficult task that has several steps, but it's important because it allows you to kind of make these various level connections between basically what kinds of claims they're talking about. Most claims don't actually have a recognizable event in them, but of the ones that do, the algorithm by default has 33 event types, and we analyzed the ones that weren't being tagged with events and discovered that there are 3 new classes of events that the algorithm just didn't know about. So we trained it to also recognize these broad cure claim, rule change, and severe weather events. You can think of them as so a cure claim is inspired by, again, the COVID and COVID vaccine development, and it's aimed at all of these claims about using various traditional or non-traditional methods to cure various illnesses. And once we trained it and we ran it on the data, and in the process of building a gold standard, we actually discovered there are a lot more claims about different kinds of things, but they're popular and reoccurring in disinformation, things like using turmeric to cure cancer and those kinds of things. Those all fall under a cure claim event. Rule change is a very broad thing. It refers to introduction of new laws, modification of existing laws, changes of rules for import-export rules and things like this. And severe weather events are tied into climate change. So severe weather events are things like large fires, storms, hurricanes, those kinds of things. So there's quite a variety of different kinds of severe weather events. And so we extended the model with these new types of events, but we also kept its ability to recognize the original events. What I should mention here is that the algorithm tries to answer a series of questions. The first one is there an event in the sentence at all or not? And that one's the most likely to be correct. Then the kind of event, then the trigger word, and then it starts adding arguments. And because there's propagating error, we haven't exposed the arguments because we've determined that it makes too many mistakes with arguments alone. So what you'll be able to see when you're searching is just event types and trigger words. And you'll see that in the demo in a little bit. Then the third kind of enrichment we're running, we call it narrative detection, but everyone has a different idea of what exactly a narrative is. So I don't want to oversell what you get out of this. We're looking at brief snippets of text, currently mostly claims, and we're kind of trying to see very similar claims that are basically variations on a very narrow theme. And we cluster them all together, and we allow you to search through those clusters. Now, this doesn't mean that the system automatically recognizes complex narratives like election manipulation, but it can recognize a cluster of related claims, such as, for example, claims that wind turbines require destroying the environment. So building new wind turbines requires destroying the environment. Then what we don't have here, but our assumption is there's this hierarchy of increasingly broad and complex actual narratives. Then they're built up, like even on their lowest level, they're built up of multiple clusters. So the example I've put in here in the bottom left, you can see this narrative that wind energy is not really green. I'll run with this example in the next slide. So you'll see the clusters that can go into it. But on the same level, there are similar attacks against solar panels, against electric vehicles, and they all combine into this broader narrative that renewable energy is bad, which is under general climate change skepticism. But equally, there are narratives about how climate change is actually not man-made, it's natural, or that it's not real at all, or these kinds of things. The structure I'm showing here is just an example. I'm not saying this is exactly how they need to be structured. I'm just saying think of our clusters in this way, where they're the smallest chunks of proto-narratives, and they get combined into increasingly more complex structures. And now here's actual examples of clusters that you can see that go into that wind energy is not actually green small narrative. And the clusters are automatically made in this case. So on the left-hand side, you can see there's a cluster of size 8, and its name, which is kind of an automatic summary, says that wind turbines burn or are not recyclable. Then there's a cluster of size 7 about claims that wind turbines require chemical de-icing in cold weather, and that actually harms the environment. And there's a cluster of size 6. So this is kind of, imagine you've run a search mentioning things like electricity, wind turbines, that kind of stuff. And a cluster of size 6 that says household electricity prices will rise. And the person examined this cluster and saw that even though it does mention wind turbines as one small part of like green energy and that its effect on prices, it's not really a cluster about wind turbines at all. And then we're examining the fourth one, where wind turbines are, the claim is that wind turbines are damaged in strong winds. And we can see the individual claims within them. It's a cluster, it's in 3 languages, it's run from 2008 to 2022. So it spans 14 years. It's been debunked by multiple organizations, and they're all different kinds of variations on the claim that wind turbines explode if the wind is too strong. So that's kind of their intended use. Now, just to give you a bit of an idea of how broad these clusters are. We started with almost 200,000 claims in the current iteration, and we kind of tried to put them all into clusters. About 50,000 clusters here, so that's about a quarter of the claims, are by themselves. There's nothing close enough for them to be clustered with, so they're kind of single claim clusters, or they're not clusters at all, depending on how you think about it. Then most of them are clusters of size 2, 3, 4. These make up for the bulk of things. So there are 2, 3, 4 times the very, very, very close claim appeared across different organizations, languages in different times. And then larger clusters become much more rare, although the biggest clusters we have are of 26 claims, I believe. And there's still, so there's this tail that's small, but it's still made up of several thousand clusters overall, where the same kind of general claim has been debunked 5, 6, or more times. We also add the different metadata to the clusters. You already saw the names. We also try to identify what are the key concepts within the cluster. So these are not necessarily something that appears in every claim or every debunk related to the cluster, but they appear either in almost all of the claims, or they are mentioned very frequently in the debunks. And in this case, again, about a quarter of, or about over a third of the clusters don't have any key concepts at all, because we want these key concepts to be kind of really definitive of the cluster. But then most clusters have somewhere between 1 and 5 key concepts identified. And those are kind of a different, quick way to get a feel for what the cluster is about if you don't want to read, or before you decide whether you need to read all the debunking articles, for example. And now the languages. I'll show you two visualizations here. One is how many languages are in a cluster. So about 60% of our clusters only have one language in them. About over 30% have 2 languages in them. But then there's still this tail end where we have about 10% of clusters are in have 3 or more different language claims in them. And the distribution of actual languages within the claims is quite broad. I've simplified this, and it's still a little bit overwhelming for a pie chart. But basically, every language that has at least 1,000 clusters, so there's a document in that language in at least 1,000 clusters, is listed here. That's, I believe, 16 languages or so. And then we have another 5.8% of the data is languages with that appear in fewer than 1,000 clusters, but still mostly in several hundred clusters. So this is all to say that our data is very multilingual, and we think that a big effect of this clustering is this ability to actually natively discover the same claim being reused across different languages, because sometimes it's the same organization or the same claim pops up in some nation multiple times, or maybe it's debunked in the US and then in the UK or Australia, and it's all in English. But very often you'll find that the more popular claims, the ones that need to be debunked over and over again, they actually appear in a whole variety of languages. And I think it's very useful to be able to discover these clusters. And we believe it's a very strong counter argument to the claim being made if you show it being debunked in 5 or 10 different countries before it even appeared locally. It is also a way to be aware that something is really going around the world, appearing in a whole variety of languages, so you know if it hasn't appeared locally, maybe it will in the near future. So these, which is the first 3 research tasks that we mentioned at the start, are all ways that we use to enrich the data. So this is a simplified view of our ontology. So this is how the data in the knowledge graph is structured. We have the text documents in the center. So these are claims and claim reviews, which are, of course, high quality articles. But we also have social media posts, news articles, and comments, which can be crawled from online, and there are very often instances of disinformation claims being spread in the wild. Then we extract the different media objects from them, including their texts. And then we have a whole bunch of enrichment tools. So one for entity linking, one for event detection, one for language tagging, one for clustering, and so on and so on. And they work with these, they analyze these media objects, mostly texts, and they output enrichments that tie back into the original documents. And we also have a knowledge of the agents. So these are the person that created the document, whether article or post, the organization that's sharing it, if it's a news article or social network, and then broadcast service is basically what channel it's being spread on. So, for example, maybe it's a news article written by person X by organization Y, and it's being spread on Telegram in this instance, for example. And when you actually query the data, you'll see the usable user interface later. But what's happening behind the scenes is we have these complex knowledge graphs, and the system runs searches on them and collects this subgraph, basically, and it extracts information out of it. So this is a typical example of where we have a claim and the corresponding review article. They've both been annotated with a number of concepts. They have these media objects associated with them. So in this case, text objects, they might have images as well. And then in addition to the concept tagging, there's also event annotation. And what I haven't shown up here is that the claim is in some cluster somewhere as well. And there's some additional types of enrichment as well that are not shown here. So now we get to see a demo of how the UI works for accessing all of these things. And I'm handing over to Nedelina for the demo.
So what you've seen so far is behind the scenes of this tool that we call the database of known fakes. It not only gathers a wide variety of sources with fact checks from more than 30 or even more now fact-checking organizations, but it allows you to use all these enrichments that we've built on top with the concepts extraction and event detection and the narrative clustering to derive insights from it. Now let's see how it looks like here. Just to briefly show you where things are on the screen. On the left, you have the concept search and the event type search. And below there are a couple of more filters. One is for the document types. So we allow it to search on the level of the claims, on the level of the reviews. And of course, you can combine all of these. They are multi-select. And also, if the news articles are the ones that are extracted from the appearance links. And of course, if you've added, because we also have this functionality to add Telegram and other social media posts, if you have them in the database, you can also filter by them if you only to see only this. I will use only claim review because we want to get the more detailed texts. You can also have filter by language, the fact-checking organization. You can see the counts for each of them. By author, of course, also a date filter. And now let's try with some examples. Let's pick the example with the wind turbines. So here you start typing and you have the autocomplete function that suggests for you the closest matches. And because it matches against the labels in Wikidata, you can start typing in whatever language you want, not necessarily in English. And if this label is present, it will match against it. So let's try, for example, sorry. and German for the wind turbine. You can see that the so-called preferred label, which is the English one, is showed in the first place, and then in the brackets you have the matching alternative label, in this case in German. You can also try the same thing. You can see, for example, in Spanish. And we only show, so in the background, a lot more actually concepts are returned matching this label, but we show only the first 7 that are, well, these are the most well connected in the graph behind, and also the most mentioned in the database. So this is kind of assuming that you're looking for something that's more prominent. So let's click on it. And now you can see how many documents, so reviews, in this case, these are claim reviews, match these concepts. You can see the number of languages, and if you want to focus on one or more languages only, you can also filter from the language filter. You have 2 types of sorting. By default, this is by date, so the most recent ones pop out on top. And there is one complex score based on Elasticsearch that matches against the relevance of your search query. But let's go with the date. I will quickly show you the visualization tab that gives you an idea of the timeline. So you can see that debunks related to wind turbines have started, so they grew dramatically since 2020 and kind of steadily reappear in the last 5 years. Here are a couple of pie charts. The most interesting one being this one that shows the co-mentioned concepts. Of course, the concept that you're looking for is always on top, but you can see the others. For example, it's interesting that Germany is one of the most prominent. So apparently this is a big thing for Germany. Let's go back to the result lists. So having seen that about Germany, you can also add it. So you can add a lot of concepts, but of course, if you add ones that have no intersection in the texts, then you'll get empty results. But in this case, you can see there are 36, as was shown in the visualization. But because I also want to show the events, let's only focus on these documents, because maybe you've seen that currently the algorithm that we're working with is only for English texts. We're currently researching for a multilingual one. So here the event types that you see, they are only relevant to the English texts from these 133 documents. So let's try, for example, attack. Let's see how many debunks are related to attacks and wind turbines. And here you have the option to explore in more detail. This is what we call document view. You have the claim, of course, the important metadata with the publishing organization, language, and date and author. We have only a very small excerpt from the text because we encourage people to go to the original article. And just to get a sense of what's in the text, we also have these quotes, as we call them, for the concepts. So here is a list of the concepts that are in this review, and also of the events with the trigger word being in bold. And as Andrei mentioned, we are currently not showing the arguments. You can see more of these. So it gives you an idea of what these attack events that we've chosen to look for are in the text. You also have a link to the claim that's associated with this claim review. Evidence and appearance links. In this case, the appearances are not linked, but we also try to embed, when there are images or videos, we try to embed them so we can have a quick look before diving deeper. So let's get back here. And let me show you the cluster search. It's in a separate tab. And here you have one more sorting option by size, which is what I'm going for. But first, let me show the visualization by date. You can see here, and beware that this visualization pertains only to the results on this page, because if we try to load it for all clusters, it will become something impossible to read, even to grasp at all. So here you can see the starting date for a certain cluster. Here, when you have this tooltip with the start and date and the duration, and of course the title, because it can't be seen here in full. So you can have an idea of when something started to appear and when it ended, at least for now, because the clusters are now pre-computed, but once new content gets in the database and we recompute this, this may shift further in time. Currently, the dots show clusters that consist of only one claim, but of course this can change in time after we add new content. So this is about the visualization, and let's try to filter by this concept that we liked for the wind turbine. Let's try by cluster size just to see ones that have more content in it. So for example, let's pick this one. There are cluster details as well, with the most important information first. We have 3 languages here, so you can see how this goes back in time. We start from bottom, which is the first appearance date in 2011, and it goes now to 2024, and all these are for energy bills rising in the UK, also in France, in Europe, wherever. You can see they're different from different sources for different contexts, but they all have something in similar. Of course, you can also dig deeper in this, but I think that's enough for now. So we don't have much time. Hopefully you have been able to see it. I'll stop sharing now and give the floor back to Andrei to show you the exciting chatbot thing.
Okay, here we go. So yes, what you saw right now is the database of known fakes UI that gives you access to all of the enrichment data I mentioned before, with various complex ways to search it. So just to go over quickly what are the tools under the hood. You saw the full text searches you saw with the faceted searches. Those are elastic faceted full text searches empowered by Elasticsearch. There's also a tab that we didn't go into about semantic text vector similarity. An autocomplete tool is something that allows it basically allows you to discover objects in the database based on their names. There's also a visual similarity search. That one we haven't gone into too much detail of, but it works in other modalities as well as text. And the thing that you haven't been exposed to is the Sparko endpoint. So under the hood, this is all a GraphDB knowledge graph, and you can actually have this really powerful querying and searching tool where if you actually know how to write complex Sparko, it can do not just searches, but aggregations, varied unique filterings, and so on, and output data that you can use for visualizations. So this is the situation right now. There's a user, whether you or me or anyone else has access to it, and that user has access to all of this search functionality that you saw, and also some search functionality that you didn't see, like the Sparko querying. And there's all this data in the back. So the searches are all just ways to access, filter, organize, summarize it, and so on. The issue we run into is that if you just give anyone, even someone who's an expert in technology, if you just give them all these various tools in this large knowledge graph, they get overwhelmed. So that's where the latest task, the chatbot, comes in. The idea is that you give either questions or instructions to the chatbot. And in addition, the chatbot has been instructed what tools exist, how to use them, when to use them, how to combine them. And it can try to get data out of the knowledge graph. And it can also explain how it got its data to you. So if you ask it a question, it might give you the answer you need, and maybe you're done there. Or maybe you want to understand how it got that answer. So you ask it to explain how it got the answer, and it tells you I used this sequence of tools with these parameters. You can go here and repeat them and see, confirm that you're getting the right results. Or maybe you ask it a question and you actually have a follow-up question and starts building and making it more complex and nuanced. So I'll show you a brief pre-recorded demo of it. Basically, one thing it knows how to do is explain what it knows about. And it's been instructed to really only answer questions about the topic it's familiar with. So it's only stuff that's in the knowledge graph itself. So I'm asking it what it knows about, or if I ask it to do something completely random, it should tell me that it only works with the database of known fakes and it doesn't have content like that. Like if I asked it to, I don't know, give me good car dealerships, that will be outside of its, oh, sorry, my video froze again. There we go. Hopefully you can read this, but it's explaining what the database of known fakes is, what it can do with it, and stuff like that. Then you can actually ask it to also get data out to the database. In fact, that's the main. Okay, my video keeps freezing for some reason. So it can be a relatively simple question. I don't know why it freezes every 5 seconds. So maybe I ask it what's the first claim from 2024 in the data set. Now I've included this here because it's one kind of hallucination that we haven't gotten rid of yet, but it's not that harmful. So we have an idea of how to fix it. But basically I asked it for the first claim from 2024 and it told me it's only been trained on data up to October 2023. We'll basically need to add one more tool that's just for the chatbot, telling it what time it is now, so it knows what kinds of questions it can answer. And in this case, I'm basically clarifying my query for it. Like I know it's not October 2023, so the database, and it hasn't called the database. This is the explain I did here. So I'm telling it, no, just go to the database and look it up for me. And it is, well, what is happening? Okay, hopefully this works better. So I'm telling it to actually query the database, which is what I needed. and it first tries to write a SPARQL query. It makes some kind of mistakes, but autocorrects. You don't have to worry about it too much. I don't know why the video freezes every 3 seconds without me doing anything. Okay, so it went and retrieved the first claim successfully, and apparently I won't be able to play video, so we'll just skip around to show you. So it went and it found the first claim from 2024, which is about Volodymyr Zelensky doing a belly dance. It was posted early on the morning on January 1st, so the debunk was posted then basically, but it was some folks claim about this happening over the holidays. So I can kind of give it very colloquial implied questions. Here I'm basically telling it, hey, I heard something about the European Union banning something to do with older cars. And I'm saying, is there something about that in your database? So is it true that people will not be able to repair their older cars? And it takes a little bit longer. And it eventually finds a claim, specifically one claim that says the EU will ban repairing cars that are over 15 years old. I'm asking if that's part of a larger larger collection of similar claims. So basically, I wanted to follow that to a cluster. And yes, it did find a cluster, and the cluster is in fact all about this proposed EU ban on repairing cars over 15 years old. And I can ask it who did the debunk, and here it will go and it would collect all the data, and it would give me a list of organizations that basically, yeah, it gave me 5 of the organizations that are in this. And another functionality that will be added very soon is it can actually redirect you to the cluster. So rather than summarize all of that for you, if you want to look at all the details, it would send you in the UI to the document or cluster view windows that Medellina showed you, where you can actually explore it all yourself and get the summaries yourself. So that's it. I'm sorry about the problems with the video streaming, but basically this is the idea. The AI assistant is a tool that can use these other more complex tools for you. It can also explain how and why it's using them, and in the process, essentially make it better. Like either you just use it to ask questions directly because you only care about getting the answers now, or if you start using it often, you slowly use which tools are appropriate to use when and how to use them. So it's kind of a trainer, and if you stick around with the database long enough, you probably learn how to use all of the tools eventually, and you don't need the chatbot anymore. Or maybe you always wanted to be able to write complex queries for you, because in addition to just doing the searches that we showed, you could also ask it to do something more complex that the database doesn't do by default, like output a graph of the number of claims that mention the 20 most common concepts in 2024 or something like that. I don't know if that would be useful for you, but it will also always be able to write these kinds of like more complex aggregation and counting queries as well. So yeah, that's a chatbot, and that's our presentation. So I think we're ready for questions.